Okay, so let's continue. Last time we started discussing the concept, the geometric concept of vectors, and it is very essential for us. Geometric. So we started with lines, and then we're going to discuss also planes. Okay. So a line is in principle a line is any equation that looks like this: P plus TV. Okay. So, and what would this stand for? This can be, and the plane, it can be any equation which is at any point P plus TV plus SW. We have not done this yet, but we'll see this one in these 2 hours. Okay, so by the end of these 2 hours, you are going to see actually, you understand a little better this one. And so, in principle, we can define a line with 2 different approaches. One approach is to give the equation of a line, which is going to look like this. We can say that y is equal to 2x. This is y1, and we can have also another y2, which is equal to 2x plus 1. Okay. So now, when we see these 2 constructs, one is there is a major difference between these 2, because one of them, it passes through the origin. The first one, it passes through the origin. The second one, it does not. Because, well, no, yes, it does not pass through the origin. And the origin, we mean this. So, this is the origin, okay? So, it's the origin. If you want to teach to a student in the 5th grade, parallel the meridiana, we have to tell them what is the origin. We always need a reference point from where we can do any kind of measurements. So let me check just where we stopped last time. I think we did a couple of examples. But now we did the inner product. Yes. So first of all, let's remind a little bit about some principles. So let's think for a moment the concept of a point. Let's say that point P, it is in fact, it can be a point which can be 1, 2, 3, 4, 1, 2, 3, 4, and let's assume that we have a point which is point P, which is 3, 1, right? In fact, point P is just a point, but if we want to denote this one as a vector, in principle, this is a vector with respect to the 0, 0. Okay, so it's a vector which is going to point like this, and by the way, this is defined as 3, 1 minus 0, 0, or this means that we have point P minus point O. Let's call it origin. Okay. Now let's assume we have another point Q, and this point Q, it says again, it can be perceived as a vector because with respect to some origin. So let's assume for a moment we have this other vector, which is 1, 4. So this can be here 1, 4, and this is also perceived that this is 1, 4, which is point Q, minus the origin, which is 0, 0, and this is again Q minus 0. Okay, but now and when we denote this vector, it points like this. What do these two vectors have in common is that they both pass through the origin. We can easily notice that one. And now we can define another vector, which is PQ. A vector PQ, it is always Q minus P. Okay? And Q minus P, Because so far, these two vectors, they were defined with respect to the origin. Now, q minus p, it is equal to 1, 4, minus 3, 1. And we get here, minus 2 and 3. Now, whenever we see this minus 2 and 3, these correspond to also to the slope, Gaussian. So slope, this is, so higher slope, it means that we have a higher rate between the delta y over delta t. A zero slope is one when delta y is 0 and it is flat, right? So this slope, this is defined as delta y over, no delta t, over delta x, okay? Assuming that we have x and y orthogonal Cartesian coordinate system. Now let's have a look here. What is q minus p? Now, whenever we have vectors, the way that we add and we subtract vectors, they go like this. So let's say this is vector A, this is vector B, this can be vector C, and if we want to add these vectors, A plus B plus C is the following: A plus B plus C. This is equal, we just bring A, or we can do it like this. A is this, B, we just bring the end of this vector to the tip of the other vector. So we bring B like this, A, B, C, we bring the end of this vector to the tip of the previous vector, this is C, and A plus B plus C, it is this. A plus B plus C. Now, if you want to calculate, so this is the answer, so let's do it like this. We can also calculate A minus 2B minus C. Then, to do this one, we just bring up A, it's a vector that looks like this, minus 2B. 2B is this, if you take it as a minus, it will change sign, so it's minus 1B, minus 2B, we are here, minus C. C is pointing in this direction, but we turn it the other way around. Sorry, I did not predict that we've done that this way up. But apparently, this vector, I could have used this better, but you can do a very good job on your notebooks. So this is the vector. So this is how we play around with the vectors. Similarly, the vector PQ, it is Q minus P. If we have here Q minus P, so let's not forget, P was this, Q was this, Q minus P, this is Q, minus P, it is going to be this vector, okay? It's a negative sign. So that if we have these two vectors, this is the same way as we are adding this one to this one. And then the answer is that from the tip of the first vector, we go to this other one. So this is the vector which is PQ. Okay, so here we have another vector. What we can notice here is that this vector, it is not passing through the origin. It's a little different. And these equations, as we said, we have one way of representing the equations like this, where y is a function of x, and then we have also a second approach, which is to use a parameter or parameterized version. Okay, so this kind of representation here, we call this, we are expressing lines. Actually, this is a line, this is a plane. For a moment, we can just focus on the equation of the line, okay? And so this is parameterized. So we can call this one, we are using parameters such as t and s, okay? Where t is any real number. What is a real number? A real number, this means that t, it is a number from minus infinity to plus infinity, including the 0. Okay, so I mean it's any number. These are the real numbers. Now let's see a couple of examples. We already have them on the board. For example, let's have a look at this equation. Y is equal to 2x. Now, this y is equal to 2x. What we can do here is that Okay, so what we can do is that we can consider one of the variables as a free variable, okay, because they will depend on each other. So we have two variables, but they are interrelated. That means that, so let's do it like this. We're going to do this analysis a lot. So we have two variables, right, x and y. That means that we have two variables. But then if they are interdependent, if there is a relationship between these two, that means that since they are not random, they are not completely independent. We just need, so two variables minus one relation. This is equal to one independent variable or parameter. Yeah, you can call it like this. One independent variable or parameter. Why do we do this one? Is that at this stage we're talking about one-dimensional constructs, which are lines, and then later we'll talk about two-dimensional constructs, which would be planes. Two-dimensional planes is this chair, for example, which means that if we have this chair like this, here we have a plane. This is just a plane. This is another plane, but then we can change the angle of this plane. So it's again a two-dimensional structure, and these will need more parameters as we can see them here. So for a moment, let's see, we consider x is equal to t, and y would be y as a function of x, which in this case, this would be y would be equal to 2x, right? But since we assigned x is equal to t, then y is equal to 2t. Then the language, so this is one way of representing lines. The other way is this one. X and y, this would be equal to, let's express now in terms of this parameter. This is equal to t and 2t, right? And then we factor out the t, we get here 1, 2. So this 1, 2, it is a very important parameter because it represents the slope, okay, the slope of this line. Now, if we pick up another equation, which would be something like y, or that's y1, whatever, or again y2, this would be equal to minus 3x plus 7. If this is the case, we follow a similar pattern we have done here. Then we say that x is equal to t, and then this implies that y2 is equal to minus 3t plus 7. So we have these two expressions, then we just need to represent what is the x and y. And x and y, in this case, the first one is just t. The second one, it is minus 3t plus 7. Now, how can we represent this expression in this form? Okay, so how can we represent it like this? We need to factor out the t. Okay, we need to factor out the parameter t, which in principle it just multiplies this parameter with a slope or with an orientation or with a direction. How can we do it? So, so we're going to have a vector here plus t times some other parameter. What is the best way to do it? First of all, we need to put here 1, and here we have minus 3. Right? Now we know how two matrices puede be matrices paraparta. When are two matrices equal to each other? Whenever each element would be equal. So if this is t is equal to t, so this is 0. That is correct? 7. Okay. So this is the parametric representation of this other line. So this means that in this case, the vector p, which is shown here, this is equal to 0, 7. And how did we call it? V. V, which was representing the orientation of the line. This is 1 minus 3. So this represents the slope. And then, so these are, I believe this is This is enough. This is the complete story. But this is how we read this. And we should never forget that t, again, it is any number in this range. Okay? Okay, that's good. So this is how we parameterize lines. Now, let's try to do an example. Yes. P and V, there are two vectors. Well, not two vectors, sorry, not two vectors. P and V, let me say it like this. This P and this V, there are these two, let me call it, these two vectors, okay? So they are represented like a vector, but the V, this represents the slope, okay? I mean, this is something which means that if we'll do a couple of examples where we can see that the slope, it can help us determine if two lines intersect or if they don't intersect. Okay. So let's it's okay. So let's try to write the equation of a line. Let's try to determine the equation of a line that can pass through 2 points, -1, 1, 3, 2. Okay, so here we go, minus. Now, this is the question, okay? We need to determine the equation of the line passes through these 2 points. What is the general expression for the equation of a line? Is this, right? So P plus TV. But again, this is the direction which represents also the slope, that is true. And the direction, let me think for a moment. Let's go over this example. So let's notice what is P minus 1, 1. P minus 1, 1, it is minus 1, 1, it is this point. So let's call this point P. Let's call this one Q. And this other one is 3, 2. 3, 2. This is 3. This is 2. So we have these 2 points over which we are going to work.
What do we call the second point?
Well, we call this one Q.
Okay.
We can call this one Q. Now, let's not get confused with what we had before. But,
so it's not related to V or anything?
No. V is a general. Now, the question is to find the equation of a line. What is unknown to us? We have 2 unknowns. This is unknown. We don't know P, and we don't know V. Okay, so we're trying to solve an equation, but what should we be looking for? We should be looking for these 2 parameters. Okay. Why? Because T, we know what is T. Charge frame?
From any real number.
Anything, right? Including the 0. This is important. Okay, so including the 0 because we see this quite often in this course that having a vector 0 in one set, it is an essential property for some concept that we make use of them. So let's have a look at this the geometric representation here. We are given 2 points, and then we need to find the equation of a line. So how can the line look like? Most probably, I mean, a line, a straight line, it's infinite. It's not like a segment, which is confined from 2 sides. So this is the line, okay? And then for this line, what we need to determine is, again, we can say that this vector v, sorry for writing it like this, I can also write it like this would be equal to second point minus the first point, which in this case, we can do something like this.
Q minus T.
That's true. Q minus T, we get 3, 2, which is this point Q. So this point is 3, 2 minus this other point here, minus 1, 1. What do we get here?
4.
We get 4, 1. That is true. So we got the slope. Okay. So since we got the slope, we need now also to find the other element. So in order to find this, what we can represent is that, let's say that this is xy. This would be equal to, this is unknown, right? Plus t times 4, 1. So we know this much, we're just looking for some other point. Now, how can we find these values? Well, one approach is the following. We can use one of the points as a reference, which would mean that if we substitute t equal to 0, this equation should be satisfied. So if you set t equal to 0, what is going to be x and y? We can use this minus 1, 1. Okay? So this is a valid equation which can represent any points along this line. Okay? Yeah. 2, 3, 2, yes. Yeah. So the general expression on this it was p plus tb, right? P plus tb. Now the slope is always there. When you say it's always there, the slope is always 4, 1. And so it's a vector which is parallel. Let's have a look actually. What is a vector which is 4, 1? A vector that would be 4, 1 would be this and this. So if we are to draw a line here, we're going to get this, and these two are parallel. Okay. So these two are parallel because this is the line, the way that it is, whose slope corresponds to this. But now the question is this: is the following. Whenever we try to find the equation of a line, to find a simple solution, would be the following. We can set t equal to 0 and find what is the other point. Okay? That's one way to do it. So if we set t equal to 0, and then we have a boundary condition. It's not boundary condition, it can be used also for much more complex situations. So if we want this equation, if we want this equation to pass through a point minus 1, 1, okay? So we have this constraint. We know that it passes through this point. So then and we set t equal to 0. What do we get from the point? Yes.
Shouldn't we substitute minus 1 and 1 to x and y?
Yes. So actually, that's what we are in principle doing. So we can say take a point.
No, I'm saying
To the first
Yes.
expression, to the first x and y, and not the.
Yeah. In principle, this is what we're trying to do. So let's say that this was two unknowns, a, b, plus t, or 1. Okay, we just did this right away. So this is what in principle we're doing. So we're just saying that this is the general expression. We don't know a and b
yes,
yet.
but both we substitute minus 1 and 1 at a and b.
Yes.
Constant minus i źreniczy do t x do epsilon na pierwszy.
Yes. Well, let's say it like this. We have two unknowns. How do we find two unknowns? We force those values to be some specific values if we apply a constraint for this general expression would like to pass to this point. Dar nu sunt sigur, when you take integral, for example, you integrate an expression, but you get a constant. To figure out what is this constant, you need an initial condition, right? You need to know the point where you have to force your line to pass. So this is similar to that one. Okay? So, yeah, we are just saying that this is a general expression. Can you provide for us any value of a and b, which can help us, for which this general expression is going to pass to these points?
Sorry, I don't know what the absolute truth of it. Am înțeles nu.
Poate ai multe și două nume și uite.
Ok, ce o să ajungem și un dimineața.
But I'm going to okay, for example, let's set t equal to 0. What do we get? Minus -1. Okay. Okay, this passes through this line, right? Then let's set t equal to 1. Let's set here t equal to 1. But then if we set here t equal to 1, let's substitute it here to get 3,2, right? 3,2 is also in there. Then similarly, we can also calculate when t is equal to 2, we will follow, so it's going to be 2 times 4 is 8 minus 1, 7, 2 plus 1, 3. So we get here 7, 3. So then this is 1, 2, 3, 4, 5, 6, 7. This is 7, 1, 2, 3. Something. So apparently, this time is continue like this, right? So we can, that's true. We can change the t for any value. It will always, or we can even try to use t something between 0 and 1. So if you set here t equal to 0.5 or 1 over 2, so what we are going to receive, the value is half of 4. This is 2 minus 1 is 1. But then 0.5 plus 1, 1.5. This is 1.5. So we get something like, apparently, this might end up being some point here.
So what if we don't pick 1 minus 1? We pick another.
Yes, okay, let's do it. So for example, let's pick this other point. So let's say again, we have this, let's say that apparently we show that 7,3, it is a point on this line, right? It looks like it's going to be something like this. So this is going to be equal to CD plus T
Times 4,
1. Again, we can set T equal to 0, and then we might get another expression, which is 7,3. But then the other points will correspond to a different value of T. Okay, so it's going to be something like this. Then if this is the new equation, okay, if this is the new equation, then let's see how can we represent a point which is, sorry, this becomes xy, the general expression is going to be this one, but then if we put here points, what was it, 4,2, no, 4,1. So then 4,1 would be equal to 7,3 minus 1, so what is this? This is 7,3, no, so 4,1, what was it? No, it was 3,2, right? Sorry. This does not pass at point 4,1, this passes at point 3,2. So 3,2 would be equal to 7,1, 7,3 minus
1 times
4,1, right? So then this just means that if we use different reference points, what will change? It will just that this will correspond to different value of t. So
yeah, well, I was saying that before I start solving the equation, you said we need to pick a point, the starting point, like in integrals, you said, because we need something forcing.
yeah.
So what if we don't pick one minus 1, for example, but pick something in the range of from 1 minus 1 to the 3,2?
It's still okay. I mean, so for example, we notice that in this expression, if we use this expression, well, if we use this one, okay, if we use this expression for what was 0.32, it was whenever t was 1, right?
Yeah.
If we use this other expression, the 0.32, it was finding the other a similar expression, but when t it was -1, okay? So you can always you can use a different reference point. You can always the important thing is being able to always write this 0.32 using two different equations. But as we said, here we use t1, t was equal to 1. Here it was equal to -1. The thing which never changes is the slope. Because the slope we can never change. Because by changing these, what you are doing is that you are traveling along this line like this. You are just going forever. So this v, this is the most essential parameter, which describes the slope. Okay. Okay. Now this was the lines. Then we can discuss about. We will solve again equations. Yes.
Give an equation on that one.
Say it again.
Y is equal to ax plus b.
We can represent that one in that way also. Y is equal to ax plus b. Okay. You want to, shall we do it?
No, I'm just asking if you want.
Yeah, this is the parameterized version. So I mean, we're using the terminology since we're dealing with vectors, and sometimes using this concept that we're using, that do provide a better understanding of space. It gives you a better horizon. Sometimes, if you want to solve electromagnetic field theory equations when you have a wave which travels in space, it's better to represent it like this. But that is true. This is the parameterized version, okay? But you are asking now if we can write it like this: y is equal to mx plus b, right? You're asking for this one. Then let's try to solve this. Let's try to write also this expression so that we don't forget what we have done for a longer time. So m, it stands for the slope. Okay. So m, this is equal to slope times x plus b. B, it is the intersection with y-axis. For example, what is the slope? Slope, it is equal to delta y over delta x times x plus b. Or, this is also equivalent to delta y over delta x derivative. We're going to do in detail the derivatives in calculus times x plus b. So they are all equivalent. Maybe this is a little more intuitive at this stage of your education. Okay? I mean, in a few weeks, you will write also this one. So what is delta y over delta x? Delta y over delta x is going to be the slope of this line. So these 2 points, we know that they're going to be there, right? So what is delta y? Delta y, it can be this one. So what is this delta y? This is 2. So delta y, this is 1, right? This is equal to, or let's do it like this. Give me a second. So where are these 2 points? You should not forget this. So this is 2 minus 1 divided by delta x, which is 3 minus 4. 3 minus
-1,
4.
1, 4.
Plus b. We know that's true. That's 1 over 4, and then this would be plus b. We need to figure out also what is the intersection with the y-axis, and let's say plus b, and this would be equal to, you said it right, x over 4 plus b. And then, let's not forget, this was equal to y. So now, here we have an expression, but it's not done yet. Since we need the relation between x and y, we should not have a third unknown. Okay, so once we see this expression, the next question is this: how do we find this? in order to find this, we need to have one boundary condition. We have to know
So
one
did you
point,
simplify
which we can
that
substitute it in there, and then we find the exact value for p. So pick a point. Which point do we know along this line that we can substitute it there? Pick one point. Minus 1, 1, yeah, that's true. Why don't we pick 7, 3? Because we kind of proved that 7, 3 was also on this line, so we can try both. So if we use here 7, it's equal to y. So it's equal to x. So let's not forget. X, y, we can do either one. But then x is 7. So this is 7 over 4 plus b. This is equal to 3. Then b would be equal to 3 minus 7 over 4, which makes this equal to 12 minus 7 over 4. Sometimes there are very difficult expressions, but problems. And if it fits in here, that means it was very easy, but this is super easy. We're going to see much complex expressions. So this would be something equal to 5 over 4. Apparently, the final equation, which is going to look like this, which we have seen this one a little longer around. This is equal to 1 over 4 times x plus 5 over 4. And it really looks like the intersection of this line with the y-axis is a little above 1. Okay? Apparently, it is a quarter above 1. Okay? Nije katakaš, se sad još bolje. Now that we wrote this one, we can also say that apparently this representation and this representation, they are equivalent. Okay? They describe the same set of points, only that here we use a parameter t, here we just use a straightforward x-y relation. Okay? Thank you for intervention. Yes.
Why did we pick 7 then?
Well, we had a free choice. We can also pick another, but allow me to take this out. This was before with this discussion.
So if we choose minus 1, 1, which is
Yes. So it's any point. So let's not forget this one. Whenever we have a constant which we don't know, we just apply the initial condition onto a specific point. We did there 7, 3, right? Let's do. We can use minus 1, 1. Okay. So let's say that we use.
Just pick a point on the line.
Yes, any point on the line where minus 1, 1 is equal to x and y. So these are two values. And then let's have a look at that expression. This is x over 4. So this is the point. This is x over 4 plus b is equal to y plus b. This is equal to y. So then substitute, insert, let's use it like this. Insert initial conditions. I mean initial, not initial condition, but boundary condition. Now you're going to listen both of these. It's either initial condition or we call this one boundary condition. To satisfy this equation, condition, then in this case we have here minus 1 over 4
plus b
this is equal
equals
to 1.
1.
Yeah, it's true. It's 1. So then b is again the unknown. B is equal to 1 plus a quarter, which makes this 5 over 4. So it looks like we find the same b for different points along the equation. But then this is what we should be looking for, okay? Because this is purely an expression of x, y as a function of x.
Sir, can I ask something?
Yes.
So the first equation, which it was 2 minus 1 over 3 minus 1, right above your hand. We have the whole equation that times x, yeah?
Yes.
Yeah, so the outcome above is 1 and below is 4, 1, 4.
Yes.
So did you simplify the next step because we see the x and we don't see the 1?
Well, I mean, yeah, it's just
Because if you did, it should be 4x.
it's the same thing, right? I mean, I believe that we can leave it like this. Yes, it's either this or this. I'm not. We're not doing too many tricks. I mean, this. So yes, x is 1x.
so the equation is going to be y is equal to x over 4.
Yes, plus 5 over 4. Yeah. Yes.
Are we gonna have the break or?
Yes, we will. But do you have any more questions? Okay. Okay, we can have a 10 minutes break.